So I'll just turn it over to him, and so you can enjoy, okay?
Awesome. Well, thank you. How are y'all doing today? I am not convinced. Let's try that again. How are y'all doing? That's a little better. All right, it's going to get better, I promise. Yeah, you guys, I tell you what, I am Jason. I'm, of course, a mad scientist. You can tell I'm a mad scientist because I'm angry. And I'm wearing a lab coat. Okay. Maybe mad might mean something different, like maybe more like crazy, right? That means we're about ready to get some crazy science going. You guys ready for some crazy science? Yeah? You ready for, oh yeah. That's what I thought. Hey you guys, before we get started with all this really fun science stuff, I do have 3 rules for us to follow. They're really easy, I promise. Can we follow 3 really easy rules? Okay, my first rule, guys. Since there's so many more of you all than there are of me all, well, I'm talking as ready for you to do. Good. Okay, if you didn't catch all of that, just remember, you got it covered. Sound good? Okay, I told you it's really easy. My second rule is also really easy, guys. You guys are sitting in chairs. That's awesome. If there's some space if you're on the floor, you can pull up some floor space as well. But I need you guys to stay seated where you are, behind this line. That way I know that you guys are safe. There are some things up here that can be kind of dangerous if you don't know how to use them. Things like, I don't know, like balloons or something. Or torches. So, please stay seated right where you are so that way I know that you are safe. Sound good? Alright. I think we can follow those first 2 rules. Now here's my favorite rule. It is the 3rd rule. It's the most important rule. Does anybody have a guess what my 3rd rule might be? Anybody? What do you think my 3rd rule is? Have fun? Yeah, what kind of a 3rd rule is have fun? Yeah, it is an awesome 3rd rule is what it is. That's awesome. Yeah, the best one. So, she's absolutely right. My 3rd rule is have fun, you guys. So, you think we can have some fun? Yeah. All right. I want to find out if we can have some fun here. So, I'm going to need you all to say that 3rd rule, have fun. All together on the count of 3. Are you ready? Here we go. 1, 2, 3. That was, yeah! That was all right, you guys. But I think we're going to try that one more time. This time, like you mean it. This is your one chance to be loud in a library. Okay? Here we go. 1, 2, 3. We are going to get to have some fun today, guys. We're going to play, well, we're going to use some science. Yeah, this summer is all about, working together, and, it's all together now, right? And so I got a lot of stuff with me about chemicals that might work together, create new things, like new chemical reactions. So I tell you what, I'd like to start off, instead of doing, a bunch of chemistry and chemical reactions, maybe I should start off with a magic trick. Anybody here like magic? Alright, I'm going to need a volunteer to come help me out here, to help me with some magic tricks. Oh, by the way, whenever I do volunteers, I take people who are sitting, who have their hand in the air, and are being good listeners. Okay, dude, you gotta come help me out. Alright, come on up here. Alright, you stand right here. Face all of your friends. What's your name? Oliver! Everybody say, what's up, Oliver? What's up, Oliver? Alright, Oliver, have you ever done magic before? No, this is the first time. That's cool. I will help you through this. Alright, there's not much for you to do yet. Can you scoot over this way just a little bit? Perfect. Maybe one more step. Perfect. Okay, now Oliver, I'm going to start off with a question. Do you have any idea what is in this pitcher? You know, it's a clear liquid, right? Like water is. Now, who would agree with Oliver that this is water? Alright, who says that it's not water? Who has no idea what's happening right now? Yeah! Actually, I'll tell you a little bit about this. It is a clear liquid. Just because something is a clear liquid, does it mean it's water? No, this is going to be something crazy. I'll tell you guys what this is. This is actually some dihydrogen monoxide. We'll come back to that a little bit later on. Now, dihydrogen monoxide sounds really scary, but you know what it is? It's water. All right. Now, Oliver, what we're going to do, I'm going to set these 3 cups up right here. And all I need for you to do is actually scoop out just a little bit for me. There we go. Right over here, buddy. Perfect. Now, we're going to pour some water into one of these cups. By the way, for you guys out here, help me out. We're going to number these. We're going to number this 1, number 2, and number 3. Okay, you guys got it. All right, fair enough. All right, we're going to put some water into which cup is that in? It is cup 1. You got it. Perfect. You guys are using some observations. That's good science right there. All right, now, we're going to mix these up. I want to see how good of observers you are. We'll put a little more into that cup. All right, I'm going to mix these up. I'm going to go really, really, really fast. So make sure you're paying attention and watching the cup with the water in it. You guys ready? Here we go! I told you I'm going to go really, really fast. Might be as fast as I can go so far. Okay. Oliver, you know what? Tell me when to stop when you think they're mixed up enough. Stop. Okay. All right. Who thinks that the water is in cup number 1? Raise your hand. Ooh, okay. A lot of you guys. If you think the water's in cup number 2, raise your hand. All right. If you think the water's in cup number 3, raise your hand. All right. All right. You know, I've tricked some people today. Actually, the water isn't it in cup number 1? All right. So, those of you that said number 1, good job. If you didn't say number 1, don't worry, because you're going to get another chance. We're going to go get, but watch. Which cup is the water in now? Yeah! You guys are sharp this morning. I love it. All right. Oliver, you guys be back just a little bit. There's people over here to see as well. All right. Thank you so much. You were like being a great helper so far. All right. We're going to mix these up really, really, really fast. Now, you ready? Set, go! Well, it's not that cup. Well, it's not the cheese, man. All right. Well, man, what's going on? Okay. Oliver, tell me when to stop, man. You're getting crazy. Stop. Okay. All right. Here's what I need for you to do, buddy. You can stand right up here in front. Now, I think I got it mixed up pretty good. You must scoot up just a little bit more. Perfect. Okay. If anybody thinks the water is in cup number 1, raise your hand. All right. Top of you. Oliver, which cup do you think the water's in? You think it's in 3? All right. So you don't think it's in 1. Face all your friends, Oliver. 1, 2, 3. All right. You got lucky. It's not in cup number 1. All right. Let's try cup. Anybody think it's in cup number 2? Yeah, a couple of us. Anybody else? All right. Here we go. 1, 2, 3. Okay. All right. You're around me, buddy. So it's not in cup 1, not in cup 2. It's got to be in cup 3. Oh! No! It came out! Wait a second. That water that came out of there, did it feel like water? No! You can hear all over it. Leave that there. I'll get it up here in a little bit. If you can hold out your hands, now, that is that water right here. What does that look like? It does look like ice. Now, Oliver, hold your hands out. Does that feel like ice? It's warm! You know, that's because I used some warm water. And actually, this is not ice here. I tricked you guys a little bit. Before you guys even walked in here, I put a little bit of something in that cup. It's a chemical called sodium polyacrylate. Can you say sodium polyacrylate? So sodium polyacrylate looks like this. It looks like powder, almost like a salt. Now, this stuff right here, it does something really special. It makes friends with water. It loves to attach to water. It makes friends with it and holds on to it. In fact, it can hold over 200 times its weight in water. So when I poured the water into that 3rd cup, that time we had this polyacrylate in there, and it soaked up that water really, really, really quickly. Now, Oliver, I can take that from you, buddy. You can go ahead and set that there in my hand. Perfect. You guys, can we all get Oliver here? Huge round of applause for him now. Thank you so much for your help, buddy. You can grab a seat for me. How did that happen here? Was there really a chemical reaction happening with all that? Hey, who says yes, there's a chemical reaction? Who says no, there wasn't a chemical reaction? Who has no actually, I can tell you, but I have to show you. Now, I'm going to need another volunteer to come help me out with this one. Let's see, how about this lady right over here? Can you come on down? Can you stand right here? Awesome. Thanks, all of your friends. What's your name? Davina? Everybody say, what's up, Davina? All right, Davina. I have something for you to hold on to here. Can you hold on to my beaker full of clear liquid? Now, do me a favor. We're going to do a science experiment, so please don't drink this water, right? I know you might be thirsty, but don't drink it, don't eat it, don't smell it either. You can smell it, it's fine. You should smell like water. Now, hold that up again for all our friends to see. And remember earlier I said, just because something is a clear liquid, does it mean that it's water? No, this could be something pretty crazy. But let's do some testing with this here. Now, this water, I kind of want to turn into, like, getting kind of thirsty. So, I think it'd be kind of cool to maybe drink something, like, does anybody have, like, a favorite drink? Like, I need to know what's your favorite drink? Ooh, Fanta, which flavor? The orange one, of course, orange Fanta. Yeah, what about you, buddy? Sprite, what about you? Ooh, Coca-Cola. Does anybody have one that's not a soda? What was yours? Well, oh, chocolate milk. That's a good one. What do you got, buddy? Ooh, dude, lemonade would be great. You know what? I feel like the idea of like juice like lemonade. Maybe we should try and make some like fruit juice, like fruit punch. Should we try and make some fruit punch? Okay, we're gonna make it out of your water and my faith. I'm gonna make fruit punch out of water and water. Alright, we're gonna try it anyway. You know, we might need magic words. Anybody have a really good magic word? What's your magic word? It's gonna explode? Well, yeah, maybe, but I need a magic word to make it happen though. What about you? Abracadabra. That's a good one. Let's do abracadabra. Okay, here's what I need. On the count of 3, everybody say abracadabra all together. Okay. Count of 3. I'm going to pour my water into your water. You're going to hold that way out in front of you, way up for all your friends to see. There we go. You might move your fingers here. There you go. You know what? If you put one hand on the bottom, help me hold it from there. There you go. That'll be perfect. Now I'll pull it up here. All right, are we ready? The count of 3. Hopefully we wind up with fruit juice. 1, 2, 3. Yes! Wait, that worked. Did you see that? We just started. I'm going to take this from you for just 1 second. Can you hold on to this one? There we go. Don't drink that either. Now, you guys, how in the world did we get this, like, fruit punch out of a magic word in 2 bottles of water? How did that work? A fruit juice powder. That's not a bad thought. But you know what? It was more than just magic. We actually had something called a chemical reaction happen just now. Can you all say chemical reaction? Yeah, put your hand in the air like this. Give yourself that huge pat on the back. That's awesome. So we had, in this beaker here that the teacher was holding, she had something called an indicator in it. Can you all say indicator? Yeah, that indicator is clear. It looks like water. And that was water in there with that indicator. So it looked clear, kind of like water. But when we poured this stuff that I was holding, something called base. Can you guys say base? Yeah! It changed the pH of this. And that indicator turned purple to show us that we had a base. So we had a chemical reaction. And that's one way you can tell we have a chemical reaction is when a color changes. So remember that, because we're going to come back to that later. So a chemical reaction can happen when color changes. But, you know, I think it'd be really fun to try to turn this back to being clear with another chemical reaction. You think we can do that? Who thinks we can do that? Alright? Who doesn't think we can do it? Who, once again, has no idea what's happening? It's what I thought. You know, we're going to try it. I'm going to have you, Davina, take this bottle here. Can you smell that? Have you smelled that before? No? You know what? Let's take this lid off here. Does it smell at all? Maybe a little bit. You know, oof. So we changed this using a base. I got to hand Davina here the opposite of a base. Something called an acid. Wait, an acid? Should I have handed Davina an acid? That doesn't sound like a good idea. But you know what? I did it anyway. And it's okay, because it's a safe acid. It's an acid you guys have probably all smelled, or maybe even had on a salad. It's something called vinegar. So here's what I need you to do, on the count of 3. I need you to pour that vinegar right on into our glass with our indicator, and let's see if we get ourselves our chemical reaction. You ready? 1, 2, 3, go for it! It is back to water! You guys, we all get to be a big round of applause. Awesome job. Thank you so very much. Nice to see you over here. Awesome. Give her one more big hand. Nice job. So we've seen a couple of chemical reactions now. We saw one turn our water purple. We saw another one turn it back to being clear. But I kind of want to show you guys one of my favorite chemical reactions. There's a type of chemical reaction called a combustion reaction. Can y'all say combustion reaction? Now that's a pretty fun one. It's a fun word to say, but it's also a really fancy word for fire. You think we should have fire in the library? Probably you should, but I'm gonna. Now, don't worry, you guys. I have done this like 2,412 times, and I've only burned down like 87 buildings, so we're gonna be alright. I'm kidding. I've never done this before. I'm gonna need another volunteer to help you though. Let's see. How about I get somebody back here? How about with the Sonic shirt on? You going up here? Come on down. You stand right here. Face all of your friends. What's your name? Joe? Everybody say, yo, Joe! Yo, Joe. Alright, Joe, I'm going to hand you something here. Can you take that and hold that way up for all of your friends to see? That's where we're going to get our chemicals working together, is in this. Now, wait a second. Does anybody know what in the world this thing is? Yeah! This looks kind of like a can or a lid. And it is. It's actually something called a film canister. Let me go back a little bit here. Back in the old days, like before we had cell phones that took pictures and things, we had to put cameras or put film in cameras to take pictures. And there's a really cool chemical reaction that happened on that film. But we have cell phones now. We can take photos and do videos instantly. So we don't really have to use for the film canister, do we? So we're going to blow it up. Now, we're going to need, though, for our combustion reaction, or our fire, I want to see what you guys know about fire. We need 3 things in order to get it to work. Can somebody tell me one thing that we need to get fire to work? We need gas or fuel, right? Absolutely. So, in this case, we're going to be using our fuel like this. This is something called ethanol. This will be our fuel. What do you got? Yeah! Oxygen! Nice job! Can y'all say oxygen? Oxygen! Yeah, we're gonna add some oxygen here. And in fact, where can we find oxygen anywhere around? How about everybody take a deep breath? Oh, that's some good oxygen. If there wasn't oxygen in our air, we would be having some problems right now. We need oxygen. So does fire. So I'm gonna add our fuel. We have oxygen in our room. Does anybody know the last thing, the third thing? This was a tricky one. Alright, what do you got, buddy? What's the third thing we need for fire? Fuel? No, I got my fuel here. That's a good guess, What was it? Soil. Say it really loud. Yeah! Heat! Good job, buddy. So we need heat in order to get our fire. And in fact, you guys watch really carefully. You're going to see a little spark jump between these two pieces. That should be enough to get us a little bit of some fire. Now, Joe, come on over here, buddy. I'm going to add a little bit of this fuel to this thing. We're going to mix it up with our oxygen. Alright, we're going to dump out all that extra right there. Alright, and we're going to put our cap on it. Now, Joe, here's what I need for you to do, buddy. I am going to put on a glove because I'm going to hold on to this thing. Now, we're going to come right on over here. I'm All right, come on over here. On the count of 3, I want you to push that button. You guys in the front row, stay seated where you are. Please don't grab this if it flies over that direction. We're going to see if we can get ourselves our chemical reaction. Are you ready? 1! Oh, if you're running a lot of noises. That's great. Have them hold your ears. You know what? I'll help you out. Plug your ears, buddy. Plug your ears. Here we go. 1, 2, 3. How was that? You good? All right. Now, Joe, you want to try it again? This time you want to push the button? No? Okay. You guys, can we get Joe here? I need you to grab the ball, go down. Awesome. You grab a seat for me. Awesome job, buddy. You know, maybe we should try it one more time. You think? Should we try it again? Okay, but maybe I need somebody else to come on and push the button. All right. Let's see. How about this guy right here in the red shirt? Can you come on down? And while this guy makes his way, I'm going to add our fuel. So that's one thing. Let's see, we also need oxygen, right? You all say oxygen? Very good. And of course, we need our heat. Can you all say heat? Heat. Yeah, we got it. All right. What's your name, buddy? What is it? Adam. Everybody say, yo, Adam. All right, Adam, here we go, buddy. Are you ready? Actually, let's go over here on this side of this chapter. All right, stand right there. On the count of 3, I want you to push that button. You guys, again, if you're pretty loud noises. Here we go. 1, 2, 3. Push my heart. Woo! Nice job. There you go, buddy. Nice job. Everybody give me a round here. I need you to grab the line. There you go, buddy. You guys see for me. Awesome. Now, you guys, I know y'all are having some fun with some chemical reactions. I'm having some fun with some chemical reactions up here. That was one of my favorites. And when we had that combustion reaction, can y'all say combustion again? Yeah, when we had that reaction, we created a lot of heat. And it was like all of that heat made the gas or the air and that fuel inside of this expand from the size of this to like the size of a basketball with an eye. And that's why this thing launched across the sky. Now, tell you what else we're going to do. We're going to need another chemical reaction. Now, this is one of my favorites. In fact, I had to bring this one to show you guys because, I know you guys are going to love this one too. Now, you guys, I'm going to need another volunteer to come help me out. Let's see, I'm going to pick somebody. How about, can you come out? You give me that third rule. You got to come help me out here. Awesome. You might actually put your shoes on for me. That would be awesome. I have some of this slushy stuff up here. I don't want to step on it. It's going to feel gross on your feet. Awesome. Come on over here. You stand right over here for me. Face all of your friends. What's your name? Sophia. Everybody say, yo, Sophia. All right. Sophia, you're going to help me out with a chemical reaction that you all, I'm sure, have seen at some point, maybe on the internet somewhere. Now, in order to get this chemical reaction to happen, we're going to have to add a couple of ingredients to my giant test, or my giant graduated cylinder, rather. We call it, by the way, a graduated cylinder because it's, it's a cylinder, and it graduated college. Okay, it didn't really. It has graduations or lines on it to tell us how much it's in. Now, we're going to add a chemical to this, something called hydrogen peroxide. Can you all say hydrogen peroxide? Yeah. Now, you guys have all seen hydrogen peroxide at home, I'm sure. This hydrogen peroxide, is not like what you put on your cuts or booze at home. This is a lot stronger. This is actually so strong, I have to wear gloves to touch this. It's strong enough that it actually burned my fingers if I did touch it. So I'm wearing gloves. I'm going to handle this part here. I don't want you touching my hydrogen peroxide, all right? So we're going to put a little bit of this in here. We're going to put, that is a really full bottle of hydrogen peroxide. We're going to add, like that much. All right. There we go. Now, that looks a lot like water. In fact, you might say, well, it is water, Jason. but it's kind of like water, except it's got an extra oxygen atom attached to it. And it doesn't, like that extra oxygen doesn't want to stay there. So we're going to add a couple of things that are going to kind of release that oxygen from that. But first, we're going to capture that oxygen with a little bit of soap. Maybe about that much. We're going to shake that around. All right. Now here comes, looking for my soup. There's my soup. Here comes my favorite part. We're going to add one last thing to this, something called potassium iodide. This is going to start our chemical reaction, and hopefully it's going to release all of that extra oxygen. Now, Sophia, can you come on over here? Here's what I need for you to do. I'm going to get a scoop of this here. All right. And I'm going to hand this to you. Be very, very careful. You got it. All right, on the count of 3, I want you to dump that potassium iodide right in there and then run. Are you ready? You don't have to run, but just stand back. All right? And then you can hand me the scoop too. You ready? 1, 2, 3! Woo! Uh-oh. You got stuck. What are you doing in there? Bro, hold on. Wait for it. It's doing it. It's going. It just had to take some convincing. Uh-oh. No! Now look at it. You guys just do it a little bit closer. We don't want to touch this because it still does have some of that hydrogen peroxide in it. But you notice, like the boy is still going. There you might see some steam coming out of this. That's because this has gotten really, really hot. We release that oxygen, but in doing that, we're also releasing a lot of heat. Guys, this is actually like when we release a lot of heat like that, it's something called an exothermic reaction. Can you guys say that? Yeah, give yourselves another pat on that. Nicely done. This is one of the goofiest elephant toothpastes I think I've ever made before.
How would you stop me?
I don't know. How would you stop it? Can we stop it? It's gonna keep going. You know, I'm gonna let it do its thing here for a little bit. I think it's slowing down a little bit. Guys, can we all give Sophia here a huge round of applause something out. Thank you so much, Sophia. Very good. Nicely done. Ugh, I'm gonna let that. You know, I gotta tell you, it smells like Dawn dish soap mixed with iodine. You've ever imagined that smell? That's exactly what that smells like. I'm ready. All right. You know, though, I think we should try another. You know, it kind of has to stop, hasn't it? Now, we're going to sit here. Now, guys, I do want to let you know, when we get done here, please do stay back at the table here because this stuff can still burn our fingers. So I need you guys to stay back so that way we're not touching anything. Now, you know, that being said, I think we should try to get another combustion reaction here or another chemical reaction. But it's one of my favorites. And I like to, like, we got some oxygen out of that, but I'd like to maybe use something else to give us some oxygen. But I'm going to need another volunteer to even start this thing here. Let's see, how about this lady right here in the purple? You can come down. Come on down. Now, while she's making her way down to the stage, come on down here. I tell you what, we're going to use some extra oxygen to test how much energy is in a Cheeto. Come on over here. Get right here. Please follow different. What's your name? Emma? Can everybody say, what's up, Emma? Alright. Emma, here's what we need to do. Now, we can't eat these, okay? These are intended for a science experiment. That, and they also expired on August 14th of 2018. So they are a science experiment. Carefully take a Cheeto. One that looks tasty. Ooh, wow, that's a giant one. Don't eat it. Okay. Good. All right, as long as we're on the same page with that. Come on around over here with me, Emma. Now, in your Cheeto here, I'll tell you what, we want to make sure that that's going to fit into our test tube here. Can you fit that in there? Oh, it does fit. That is a giant Cheeto. I tell you what, let's break this one in half here. I'm gonna put half of it back. We'll take the bigger half. You take the bigger one there. Hold on to that. All right, your job is to hold on to that Cheeto. Okay, can you do that for me? All right. Now, while she's holding on to that, I'm going to add a couple of chemicals here, or one chemical, to our test tube. Something called potassium chlorate. You guys have done really, really good with big words. Can you say potassium chlorate? Yes! Say that one more time. Oh yeah, and give yourself a huge pat on the back once again. Nicely done. So this potassium chlorate, when we heat it up, is going to start releasing a lot of oxygen. And as it releases oxygen, it's going to become a really oxygen-rich environment inside this. Which, by the way, remember, it's something we need for fire. So we're going to test how much energy or how good of a fuel a Cheeto is going to be. Now, Emma, I might actually have you back up just a little bit here because I've got a flame going on here. All right. And then when I say now, I want you to hand me that Cheeto and run. No, you don't have to run. You can just stand right where you are. That'll be perfect. All right? All right, we're heating this up. We're starting to see it like right now. You can see it's a solid in there. It's like a powdery solid. But as I'm heating this test tube, it's starting to heat up that potassium chlorate. And as it's heating it up, it's starting to melt, just like an ice cube in there. Except this melts a lot hotter than an ice cube. Now, oh, there we go. Now I have a liquid in there. And as I have that liquid, it has a lot of oxygen in there too. All right, Emma, I will take that Cheeto. Run. No, you're fine, Sarah. All right. Hey, that's perfect right there. Are you guys ready? Let's see how much energy is in this Cheeto. 1, 2, 3. Oh, we got a little bit. Oh my goodness. I'd say there is some energy in that Cheeto. What do you think? Wow, there was a lot of energy in that Cheeto. I'm going to put that Cheeto in here because it is smelly. That is how we make flamed hot Cheetos. You guys, let's give Emma here a huge round of applause for now. Thank you so much for your help, Emma. You guys see for me. Very, very nice. If you get a whiff of that, I apologize. It's almost like an overcooked Cheeto, which is exactly what it is. Now, you guys, I know you guys are having a blast. I'm having a blast with you guys. Are you guys having fun? Okay. Now, you guys, I tell you what. Unfortunately, I am about out of time. But I have one more experiment to show you guys here. One experiment, but there's 2 chemical reactions that happen with it. But I need another very brave volunteer to help me this time. How about, did I get this guy way back here in the maroon shirt? Can you come help me out? Come on down, buddy. Come right on around over here. Now, as he's making his way to stage, where did he go? I found it. All right. This is very important stuff. You know what this is? Okay. You've got, we can call it aluminum foil. Does that sound good? What's your name, buddy? Dalton. Can we all say, what's up, Dalton? All right, we're going to work together on this because, working together, that's kind of what our chemicals are doing. I'm going to rip off some pieces of some aluminum foil, and I want you just to stick them right there in that flask for me. All right, this is the first, I told you I was going to hand it to you. There you go, crumple them up a little. Go ahead and take that, there you go. I'll help you out there, stick that in there. They don't have to, crumple them up too tight because, we just need them to fit in there, and we need them to be kind of loose. So that way we have a lot of what's called surface area to react with. There we go. And you keep doing that. I'll let you handle that. You know what you're up to. You're a pro. Have you done this before? Okay. You know what you're doing. All right. Now, while he's doing that, we're going to add another chemical to this. Remember we called this stuff dihydrogen monoxide?
What?
Yeah! Yeah, bro. Nice job. So it is water. And this guy's going to grow up. He's going to be like, I need dihydrogen cross-eyed. People are going to look at him like cross-eyed. What are you talking about? He's like water, man. So we have our dihydrogen oxide. We call it that because we have 2 hydrogen atoms and 1 oxygen atom. Remember that because that's really important for this reaction. So here's what we're going to do, though. I want to put this in here, and I want to see what you guys have learned here in the last 45 minutes together. All right. We put our water with our aluminum foil. Are we getting a chemical reaction? No, we're not. Good job. Because, here's a question. Here's another way we can tell. Can we separate our water and our foil? Yeah, I can dump the water in the foil out, let the foil dry, and they're separated. Nothing has changed. So we're going to add one more chemical to this. Something called, actually I'm going to add just a little bit more water. And we're going to add something called a base to this to start our chemical reaction. Now this is the part, Dalton, where I might have you take a few steps back for me. Perfect. Right there, you might come this way just a little bit. Right there, perfect. Maybe that way just like half an inch. No, I'm kidding. All right, now we're going to add one last chemical to this, something called sodium hydroxide. Remember earlier we talked about acids and bases. And some acids can be really, really strong enough they can burn us. Some bases can be really, really strong enough they can burn us. This base is such a base. So I have to wear a glove in order to handle this stuff because it can be dangerous. So we're going to add a little bit of it to this. I'm going to measure it out perfectly. And what's that? And maybe a little more. And maybe a little more. Is that perfect enough? And a little more. All right. That looks pretty good like that. Now, we're going to mix that around in here. And hopefully, ooh, is our color changing? It has. Remember earlier we talked about how the color changes and it creates the chemical reaction could cause a color change. We're going to get that in there, get that nice and sealed. We're going to seal the top of this here. Ooh, come on over here. Now, that's something we didn't really talk about a whole lot, but can you feel the bottom of that? What's it doing? It is getting hotter. Our chemical reaction, like our elephant's toothpaste, it is creating heat. What's happening to my balloon, too? It is blowing up, isn't it? It's definitely inflating. It hasn't blown up yet, if you know what I'm saying. Now, we are actually creating something in here. We're creating something new. There's tiny, tiny, tiny little bubbles that are forming in this. And those bubbles are something called hydrogen. Can you all say hydrogen? Yeah! Now, hydrogen, if you don't know, hydrogen is the most abundant element, the most abundant building block in our whole universe. There is a bunch of hydrogen all over the place. It's also the very simplest. In fact, it's so simple that it should actually float in our air, just like a helium balloon that you might get at a party. Now, those balloons that you get at a party, they float. But they float because, again, they're full of helium. There's a reason we give people helium balloons and not hydrogen balloons. That's because hydrogen or helium likes to be like by itself. It doesn't want to mix with other things. Hydrogen, though, it likes its friends. And when it meets its friends and wants to like become friends, it like does so explosively. So, is our balloon full enough, you think? Does that not hydrogen? Who says yes? Yes. Who says no? No. All right, I'll hear you. All right, we'll add a little bit more. That's looking pretty good. You know what? Actually, I'm going to go ahead and take this balloon off of here because I think this one's big enough, and if we do this right, we might be able to get a second balloon out of this whole deal. Now, Dalton, I'm going to try this balloon off. What I need for you to do is see that it floats. Oh, it does. Oh, yeah. Can you hold on to that 2 hands? Don't eat it. Don't drink it. Don't think about it. Just imagine that you're going to stand still. All right? Woo! That balloon is talking. That is one exciting balloon, you guys. All right. Ooh, we are going to get a second balloon. This is going a lot faster, isn't it? All right, go balloon, go. You know, if you look inside of this, it's really bubbling down. That's because our chemical reaction is creating a lot of heat. And a lot of that heat faster, it creates more heat. And it creates more heat, it goes back. You get the idea of what's going on here. Since this one, I think, is like a little more complicated. Ah! No! You know what? It'll be fine. We'll let this guy sit here all on his own, I guess. I'm going to open this up, let that fence a little bit, because that has gotten really up. Where you going? I'm sitting right here, man. All right, yeah, it's probably safe. All right, we're going to, there we go. Now, you know, I think it's time that we did something with this hydrogen balloon that you're holding right here. We're going to see how, powerful this hydrogen is. Now, remember, this whole thing came from water, which is hydrogen and oxygen. There's oxygen in our air. We have a balloon full of hydrogen. So, I wonder now if we can make another reaction that might do something special. So, I put some tape on there. I'm going to stuff some tape to a stick. And then we're going to take this. All right. Now, I'm going to tape this guy to the balloon. And then, I'm going to go right over here. All right. If you're afraid of loud noises, now is a great time to plug your ears. Dalton, you can stay right there, or you can even come a little closer. It's fine. There you go. A little closer to this table. All right. You guys, did you guys have fun today? Yeah. You know, Miss Janice back here was telling me earlier that this is like the 100th year anniversary of this library. And so I think it would be kind of fun. I have a birthday candle here. Yeah, it's just one for 1 century. This is our birthday candle. We're going to see if we can blow it out with our special balloon we made. Are you guys ready for this? On the count of 3, we're going to get it to happen. Actually, let's count down from 5. 5, 4, 3, 2, 1. Woo! I think we got a reaction. Now, you guys, over or Dalton rather, check out. Do you see something on the inside of that balloon there? What does that look like? It looks like water. You know why? Because we literally just made water with our chemical reaction right here. When we combine that hydrogen with the oxygen all around us, it released a lot of energy and made water. You guys, can we give Dalton one more big round of applause for helping out? Thank you so much for your help, buddy. Yeah, you guys, I had a blast hanging out with you guys. Like, literally a blast hanging out with you guys. I hope you guys had a good time hanging out with me as well. I tell you what, let's do. Let's give Valley Center Public Library a huge round of applause for having guys sign up here today in 100 years. And also, keep thinking about all the science fun that we had today. Think about how you're using science today. Like, you can use science all over the place. And you might even be able to find a book or two about science at the library. I would imagine. Guys, I'm going to turn this back over to Miss Janice. She's going to let you guys know a couple of important things about the summer here. All right, Miss Janice, they're all yours.